Variable oxidation states of the transition metals. A characteristic chemical property of the transition metals is that they have variable oxidation numbers or oxidation states. All transition metals can have an oxidation number of +2 as they lose the 4s electrons first. So here you can see the electron configurations of the transition metals, and with the exceptions of chromium and copper, they all have two 4s electrons, and they can lose these 4s electrons. They lose them first, so all of the transition metals, including chromium and copper, can have an oxidation number of +2. In this table, you can see the common oxidation states of the transition metals. So the common oxidation state for titanium is +4, for vanadium it's +2, +3, +4 and +5, chromium +2, +3, +6, manganese +2, +4, +6, +7, iron +2 and +3, cobalt +2, nickel +2, and copper +1 and +2. The oxidation states that I've highlighted in red, so for chromium it's +3 and +6, manganese +4, +7, iron +3, and copper +1. These are the oxidation states that you need to know for these four transition metals. And don't forget, these oxidation states are in addition to the fact that all transition metals can have an oxidation state of +2. So to understand why transition metals have variable oxidation states, we'll have a look at the comparison of successive ionization energies in calcium and chromium. So if we look at calcium first, you see a big increase between the second and third ionization energy. So we look at the electron configuration for calcium. The 4s electrons are lost first, and then this big jump in ionization energy corresponds to the electron being removed from the 3p sublevel. The 3p sublevel is at a lower energy than the 4s. It's also closer to the nucleus, so there's a stronger electrostatic attraction holding the electrons, so more energy is required to remove the third electron. So if we look at the successive ionization energies for chromium, we don't see the big jump until the 7th electron is being removed. And the reason for this big jump is the 7th electron is being removed from the 3p sublevel. The first 6 electrons that are removed, they are being taken from the 4s and 3d sublevels. Because the 4s and 3d sublevels are quite close in energy, there's no big jump until we remove the electron from the 3p sublevel. So to summarize, calcium has a large increase in ionization energy when the third electron is removed, whereas chromium shows a large increase when the 7th electron is removed. This is due to the closeness in energy of the 3d and 4s sublevels, and this is the reason why transition metals have variable oxidation numbers.